Hi. Welcome back.
Hello.
We've missed you. I hope you had a great weekend. We are recording. We're live. No, I'm not streaming live. So we're working on Unit 9, Day 3. This is the Algebraic Transformations. And as you may have already noticed, due to copier issue, we are working on lined paper today. Right. Y'all have requested that I work on number 6. So when you're working on these at home, doing your homework, please format it this way. Put the title along the top, the item number that you're working on, and then we're going to write out the directions really quick. This says the directions for this section are describe the transformation. And we've been given this function and this transformation. Sorry. All right. When you're looking at describing the transformation,
Ma'am,
yes?
I need Jonah Jaramillo to report to the office. He's leaving.
He's on his way.
Thank you.
You're going to look at this one. Okay? You're not going to look at this one. You're going to look at this one. Okay? So looking at this one, what does this part ask you to do? It is a reflect. Across which axis? Good. So this is reflect x-axis. Very nice. And when we're looking at this one, what does this ask you to do?
The horizontal. No. Where is it?
Yep.
Horizontal.
It's a move to the left, horizontal translation. That was the word on the tip of your tongue. You said left 3? Very nice. And then what does this ask you to do? Beautiful. This is the vertical translation. I'm out of space. Which direction? Beautiful. Just write that as a complete sentence. And that's the answer for this item. Okay. Does anyone want to see me write it out as a complete sentence, or are you happy with what we've got? I got a couple people raising hands. Okay. Let me just. Okay. The function p of x equals 1 over negative x minus 2 was reflected across the x-axis and horizontally and vertically translated. Translated horizontally, left 3 units, and vertically up 8 units. All right, I've written my little 1-sentence paragraph thingy. I'm done with this one. Ask me your question about this item. I love it. I've got a couple people taking pictures of this. That's pretty awesome. Mm-hmm. Yeah, but I got a couple people take a picture so that they can focus for now, and then they'll write it down later. Right? Yes. If you're one of those that can't focus and write at the same time, like, take the picture, write it later. Yeah, but just focus. That's all I ask. All right, let's go ahead and look at number 12. The directions on number 12 say apply the transformation. All right, we have been asked to take this function p of x and apply this following transformation. Okay? This is literally the one we just finished doing, but this time, instead of just describing how it gets changed, we're going to actually go through and change it. But not changing it on the graph, changing it algebraically with all of its symbols. Okay? So one thing you'll notice is that we've got a negative sign in front of the call for the function. That means that I'm going to do that negative sign, and I'm going to put the function in a box. This is the function I'm putting in a box. Inside of that function, I notice that in the parentheses, I have something other than just a plain old x. That means inside of this box, anywhere I see an x, I'm going to replace it with all of that. So I'm going to rewrite d of x with the following changes. The first thing I see on d of x is a negative. Then I have my box. So I'm going to write my box. In my box is the p of x function, which is a 1 up here, and then a negative. And as I see, I've circled my x. That means that I'm going to replace it with this stuff. I have finished writing what x was, and so continuing with the function that's in the box. There's nothing else to write. I'm going to close my box. I have finished writing this box, and now I'm on to this portion of my new transformation, and I'm done with the setup. This is where you could get way off base. Ask me a question on this. Other than you can't really see what this says. I'm sorry, I just realized that. I turned around and I saw that was very bright. Okay, so the setup is okay? All right, let's clean it up and get down to our final answer. First thing to do is we're going to look at the very innermost parentheses. That's this one right here. And I'm going to distribute this negative sign right here. Okay? So that's going to be the first change I'm going to make. Everything else I'm going to write and keep exactly the same. We're just going to see the little change right here. And the parentheses are getting removed. Are we all right with that change? All right, now that we're okay with that change, I'm going to go ahead and add these two pieces together. Everything else is going to stay exactly the same, so you're just going to see that one little change. Now I want to get rid of those parentheses, okay? Which I can, except now I've got a bunch of negatives sitting there, and I want to also deal with those. So what I'm going to do is on that denominator, you see how I've got this negative sign in front of the x? I'm going to factor out a negative from just the denominator, so then I can move it somewhere else, and you'll see that it ends up disappearing, okay? So the first thing I'm going to do before I do the factoring is I'm going to remove these parentheses, and I'm going to bring this negative, and I'm going to put it right there on that numerator. Okay? That's going to be the only change I make on this step. Okay? So I got rid of the parentheses, the boxy parentheses, and I scooted that negative over into the numerator. Now to factor the denominator. To factor the denominator, or to factor anything like this, when we're looking for common factors, I'm going to take each one of these terms, each one of these items, and I'm going to rewrite them so I can see all of the factors involved in that particular term. To get to negative x by multiplication, I can take negative 1 and multiply it by x. You agree? Okay. I'm going to do the same thing with the negative 5. I can get to negative 5 by multiplying negative 1 and positive 5. Okay? So now I'm seeing the factors, just the factors of just that denominator. Now that I have the factors written, it becomes very easy for me to see which ones they have in common. In common is the negative 1, which means I'm allowed to rewrite this particular expression as negative 1 times the group of whatever I get with what's left over. Okay? Now, it's entirely possible that some of you can see from this step to this step without having to go through all of this in between. Some of you need this in between. I'm showing you the in between because really soon you're going to have to do these, and these lines up here get really complicated. Okay? But it's the same process, and it actually makes those complicated things easier. Okay? So I'm getting it complicated now while it's simple. Okay, so we're okay with me replacing this with this. All right, I'm going to do that over here because I'm out of space. Okay, so d of x equals negative 1 over negative 1 x plus 5 plus 8. And now it's really easy to see I've got a double negative happening. Negative divided by negative is? And so my next line doesn't have those negatives in there anymore. I can't have the 5 and the 8 interact because the 8 is a whole number and the 5 is stuck in some part of a fraction. I don't want to make a bigger mess and add more fractions to try to force the 8 and the 5 to interact, so I'm done.
Miss, how come it doesn't turn into 5x?
Great question. How come it doesn't turn into 5x? The reason is because this means x plus 5, and this means 5 times x. All I'm doing here is taking whatever this number this is and adding 5 to it. This means take some number and multiply it to 5. Add it to itself 5 times. So these two, not the same thing. Okay, great question. Any other questions about this item? All right, I'm out of space on this paper, so I'm going to switch paper and I'm going to look at number 18. If you want to go on the back of the paper you're working on, that's fine with me. So meet me on a new sheet of paper, new space for number 18. 18 is another apply because I don't have a new set of directions, so I'm going to apply the transformation again. Ladies, stay focused, please. Thank you. My original function is p of x equals 1 or negative 1 over x plus 3 plus 13. And my transformation d of x is p of 2x plus 2 minus 5. Looking at my transformation, I see that I have stuff in the x position that I'm going to replace. And I also see that I'm calling the function and doing some other things to it, so I'm going to go ahead and stick it in a box. And I'm going to stick the entire function up there in a box so I can see what I have to write. All right, first line of substitution and setup. D of x equals, immediately go to the function. Negative. I have to put stuff in parentheses. I have to put 2x plus 2 in parentheses. Okay. Trying to make the negative look different from the thing. Okay, continuing with my function, I have to add 13 at the end. My function is done. minus 5. Okay. Question on setup? I put it in a box up here, but I didn't write the box here, and it's because I've got nothing I'm multiplying out here in front that I have to try to keep track of distribution on. Okay? So that's why there was no box on the next line. All right, looking here, I don't need the parentheses in the denominator, so the very next line I'm going to write is keeping everything the same, except this denominator I'm going to write without the parentheses. Well, I might as well go ahead and take care of these things right here. 13 minus 5. 13 minus 5 is?
8.
Yeah, and then I'm going to go ahead and add the 2 and the 3 together. Is that too dark to see? Yeah, a little bit. I'm going to add these two together. And then I look for stuff that I can do. Oops. Got to clean my camera. I scratched it with my pen. I got it dirty. I don't see anything else I can do. Can't add the 2 and the 5 together. Can't add the 5 and the 8 together. I really don't want to move the negative. Okay, nothing else I can do. I'm done. That's it. Okay. All right. Moving on to number 25. I'm going to grab a new sheet of paper. Try to clean my camera lens a little bit. That's a little better. I'll get some Windex on that in a second. All right, look at the number 25. Directions on 25 says, draw a sketch. There is a difference between draw a graph and draw a sketch. Draw a graph has to be precise. I'm giving you coordinate grids. If there is a graph located at the point 2, 1, then I better see a graph located at the point 2, 1. A sketch is, as long as you give me the important information and it kind of looks sort of like it's supposed to look, we're good. Sketches are definitely a lot less stressful. Okay. We've been asked to draw the sketch for f of x equals 1 over 6x plus 3 plus 2. Notice the pause there was intentional. 1 over 6x plus 3 plus 2. Okay, so that plus 2 happens at the end. As you're getting ready to draw this sketch, you need to be thinking about what the parent function is and looks like for this particular type of function. This type of function with a fraction variable in the denominator has its parent function as 1 over x. And it looks like this. Vertical asymptote on the y-axis, horizontal asymptote on the x-axis, function here, function here. When we are done graphing this particular item, it's going to look like some sort of shifted, moved around version of this one. So the first question to ask yourself, are there reflections? Good. No reflections. This means that it's going to be orientated this way. Something on the upper left of the asymptote, something on the lower left of the asymptotes. If we had a reflection, we'll see it appear in different places, depending on the reflection we've been given. Okay? All right. The next thing to ask ourselves is, where is the horizontal asymptote located? Right there. That's the horizontal asymptote at y equals 2. The next question to ask yourself, Where is the vertical asymptote located? Where that equals 0. The vertical asymptote happens wherever the denominator of the fraction equals 0. The vertical asymptote is located wherever the denominator equals 0. So let's go figure out where that is. Here's the denominator. Equals 0. Okay, let's solve that for x, and we'll figure out what value of x makes the denominator 0, and that's the location of our vertical asymptote. Gonna subtract 3 from both sides. Gonna divide both sides by 6. I'm reducing the fraction. That's our vertical asymptote. I took the denominator, I set it equal to 0. Because anywhere the denominator is 0, we have a vertical asymptote. Then I solved it for x. Okay? We have all the information we need to graph it. We know that there's going to be no reflection, so it's going to be located on the upper right and on the lower left. I know where the vertical asymptote is. I know where the horizontal asymptote is. I can sketch my graph. So I'm going to do it. Draw in some axes. Maybe label them. I don't know. All right. Horizontal asymptote at y equals 2. That looks like a good spot for y equals 2. I'm going to go ahead and label it. Y equals 2. Vertical asymptote at -½. That looks like a good spot for -½ Not drawn to scale. Because it's a sketch. It doesn't have to be drawn to scale. No one cares what the scale is. It's a sketch. As long as I label appropriately and put things in kind of the general sort of place it's supposed to be, we're good. All right. Upper left of the asymptotes, not of the axes. Upper right of the asymptotes. Lower left of the asymptotes, not the axes of the asymptotes. Lower left of the asymptotes. Your graph should look a little something like that. Questions? Shaking head silently is okay. Feeling okay with it? Good. Ladies in the middle, we're all right with this? You can do it on your own. Maybe you're going to give a shot and then call me over in a small panic. Okay, sounds good. That's all I had for today. Thank you.